Hey, all you cool cats and kittens. Welcome to another episode of Science TV with Mr. C. I'm your host, Mr. C. And as you can see from the background, we are on location in my classroom today. Hooray! Let's get started. Today, April 24th. Looks like it's going to be a nice day out today. I hope so. Yesterday was wet and gross. Anyhow, first thing we have today, we're going to do some ionic bond reviewing. We're going to need the periodic table for this, so you might want to get a copy of that pulled up for you. I have my copy right here. And here is the table we're going to be doing. Oops, figure that out. All right, so what we're going to do here is we're going to find the positive ion, the negative ion, and the formula. For potassium bromide, calcium oxide, here we have sodium chloride. So to find these, we're going to find them on the periodic table. Sodium chloride. Positive ion is always going to be the element that loses an electron. So if you have 11 protons, 11 electrons, and you lose one electron, you now have 11 protons and 10 electrons. You add those together, it gives us a positive charge of 1. Every time here, the metal is the one that loses electrons, so the metal is going to be a positive ion for every one of these. So we're going to find out what the symbol for the positive ions are, and we're going to find out what their actual charge is, but we'll get that in just a second. So sodium chloride. We're going to find sodium on the periodic table. Sodium is located right here in group 1. Notice it has 11 protons. If it's in group 1, it means it has 1 valence electron. So remember, if you remember back to last time, if we have 1 valence electron, it wants to get to a stable level. Stable's 8. Now to get to 8, is it easier to lose 1 and go back to 0, which would drop down a level? That would give us 8 in the previous level, or add 7 electrons. This is easier to lose just 1. So when you lose 1 electron, you get a positive 1 charge. So the way we're going to enter that is sodium plus. The negative ion is going to come from the chloride, chlorine. So on our periodic table of elements, we're going to find chlorine. It's located underneath my back shoulder here. Chlorine. This is group 17. That means it has 7 valence electrons. So that means it's going to gain 1 electron. If you have more electrons than you do protons, you're a negative ion. So on our table, we're going to put chlorine negative. Our formula for this, NaCl, salt. That's a pretty easy one. Now when it gets a little more difficult is down here with, like for instance, lithium oxide. Let's do this real quick also. Lithium. In our periodic table of elements, lithium. Where's lithium at? It's Li. It currently has 1 valence electron. It's going to lose that electron. So we're going to come back to our table. Lithium oxide is our positive ion. Type in Li for the chemical symbol. And for the plus, what I would like for you to do, come over here to charges. Click on the plus box. Copy that. Control C. Come back over here. Right after the Li, Control V. Lithium plus. Center. It's done. Next is oxygen. We'll find oxygen in our periodic table. Oxygen is over here in group 16. That means it's going to need 2 electrons to get to 8. So it's going to gain 2 electrons. That means it's going to have a negative 2 charge. We were writing that. I wrote that wrong on this one. Type in O for the oxygen. Now since the negative 2 charge, we got to write that a little bit different. We need 2 electrons. So to get that, we're going to need to write this a little bit differently. So since it needs 2 electrons, we're going to use the number 2. We're going to use the superscript, which I need to fix my spelling error. There we go. Oh, that's not any better. We're going to use a superscript for this box here. It needs 2 electrons. So 2 Control C, Control V, and since it's 2 electrons, the electrons are negatively charged, we're going to come over here and get the negative charge. Control C, over here, and Control V, 2 electrons. That's the negative ion and the positive ion. Notice here we have Li2O. It's a little different than the one we did up here. It's because we're going to start working on balancing equations with this. Balancing equations. So, the way that works is lithium is short 1 electron. Oxygen has 2 extra. We need to make that 2 and the 1, they have to equal each other. For this oxygen, or for this molecule to work out, for that to happen, this ionic bond, oxygen needs 2 electrons, so it's going to take 2 from lithium, but it can't take 2 from lithium. So instead we'll have 2 lithium atoms. It's kind of like when you are adding 2 fractions together. So you've got 1/3 plus 1/2. You can't add them together, they don't have the same denominator. So what you'll do for that is you try to find the common denominator for the 2. In this case, the common denominator is 6. To get 3, 6, we need to multiply it by 2. To get 2 to 6, we need to multiply it by 3. So these top numbers will change as well. We're kind of cross-multiplying. So our example of lithium and oxygen, we have 1 lithium, 2 oxygen. The lowest common number we have here is 2. So we'll take the oxygen side, which is 2 times 1, which means we still have 1 oxygen. We'll take the lithium side here. To get the 2, we need to take it times 2, so that means there are 2 lithium atoms. Hopefully that makes a little bit of sense. We'll try another one here. Aluminum sulfide. Aluminum on our periodic table is right here in group 13. So that means it's going to lose 3 electrons. So we'll add the chemical symbol of Al. Since it's losing 3 electrons, it's going to have a positive 3 charge. So get our Al here, over to the amount of electrons it's going to get. This is a superscript. It's going up above. 3. Control C, back to Al, Control V, 3 watt. Oh, it didn't work right. Do that again. Control C, 3, and then Control C, V, 3 plus. Sulfide, sulfur. Where's sulfur on the periodic table? It is in group 16. So it's going to need 2 to get to 8 valency electrons. Chemical symbol of S. S. Getting electrons means the charge is going to be negative. We needed 2. Superscript 2. Control C right there. Control V. That's a subscript, isn't it? Superscript says right here. Control C. Control V. 2. And electrons. 2. Negative. 3 aluminum, 2 sulfur. That's kind of like this example here. We're going to need to get to 6. So Al has 3 already. To get to 6, we're going to take it times 2. So Al times 2, 2 Als. This time we're going to use the subscript. Al, Control C that. Control V that. Our next letter is S. S is 2. We need to get to 6. So we need 3 of those. So S, Control C there, Control V there. That works out. Math is good. If you have questions, please hit me up. I'll do what I can to help you with that. Fill out the rest of these. Make sure you copy the address, you share it, and you submit it. next on our calendar. Review slides 16 to 22. We're going to talk some more about ionic bonds. Looks like some people are already looking at it. We're going to explain how ions form, formulas, the naming of it, how they're written, and identify some properties of it. Like another concept map that we haven't done again for a while. So we're going to explain how ions form. An atom, or group of atoms that has an electric charge. We were showing earlier how the sodium loses electrons, oxygen gains electrons, and what this is saying here. So that's how ions form. When you lose an electron or gain an electron, if you are a charged atom, negative or positive, you're considered an ion. There's lots of common ions out there that you've probably heard of. Here's a group of some of, or list of some of them. Notice how some of them are made up of several atoms. Those are called polyatomic ions. We talked about genes. Polygenetic. Poly means many. Atomic means atom, so polyatomic, many atoms. Here we have some common positive 1 ions. We have potassium, silver, sodium, hydrogen, and ammonium. Notice ammonium is a polyatomic ion. It has 5 atoms in that. We move to 2. A lot of these are group 2 elements. Barium, calcium, lead, that's a new one for us, magnesium, and nickel. That's also a transition metal just like lead is there. And then the plus 3, aluminum, we just worked with, and chromium. That means they lose 1 electron, they lose 2 electrons, or they lose 3 electrons. Now our negative side, where we're gaining electrons, well, these are going to be non-gases. Chloride, we worked with. Fluoride, iodide, nitrate, one of the polyatomic ones here, bromide. Then we have carbonate, another polyatomic, chromate, oxide, sulfate, peroxide. That should sound familiar, right? Hydrogen peroxide, phosphate, and phosphite. So those are some common atoms. Now, ionic bond is where oppositely charged particles are attracted to each other. Negative plus a positive. Opposites attract here. This is called an ionic bond, and that ionic bond is called an ionic compound. So the bond is where they stick together, and that between the 2 different elements is called the compound, the ionic compound. Now, when we write these formulas, we always want to make sure we're showing the ratio, H2O. That's the covalent bond, but notice how there has the ratio, the 2 hydrogen to 1 oxygen there. To write the formula for these ionic compounds, we always write the symbol for the positive ion first, which means the metal will always be first in these. Please remember that. The subscript, which we worked with a little bit there, is the ratio of elements there. So H2O, 2 hydrogen. MgCl2, 2 chlorine. Subscript is talking how many atoms. The superscript we were working on before is the charge of those. And we name them. Positive ion, again, comes first. You write it first. You're going to speak it first. The negative ion comes second. The second syllable of the nonmetal is dropped and replaced with IDE. So, for example, sodium chlorine. We drop the second syllable. It's not going to be chlorine. We'll drop the INE part. We're going to replace it with IDE, chloride. Sodium is a metal. It loses an electron, becomes positive. Chlorine gains the electron. It becomes negative. Chlorine uses the ion, replaces with the IDE. Now, ionic compounds have some properties. One, they're made up with crystals. If you remember back to minerals last year, minerals have crystals. They're repeating patterns of ions. They're hard. They're brittle. They have a high melting point. The high melting point is because opposites attract. That's very true, especially in chemistry. And when you dissolve them in water, they will conduct electricity. When they're dissolved, the ions are able to move about freely, and it allows the electrons to shoot from atom to atom to atom. So those are some of the properties of the ionic compounds to remember. that's it pretty much for the review. On Monday, there's probably going to be a little quiz over some of these things, so I would look it over. If you want to make your own concept map, you are welcome to, but you are not required to. With that, we have one other assignment. There should be a text box submission form for this, reading a little bit about ionic bonds, how they move away from things, how they move towards things, and then there are 4 questions following up. If there are any questions, please hit me up on the ChatterDoc, email, or however you like to communicate. I hope you have a wonderful day, and thank you for watching.